It's exciting to be here, and I'm happy to share my story about this great program. Once again, my topic of conversation will be regarding beaver dams. Specifically, this is titled Building Beaver Dams and Building Resilience, using the faculty mentoring network to springboard fun field-based labs and undergraduate research projects. And this story begins 2 years ago when I was still teaching in Idaho, specifically at the College of Southern Idaho, located in Twin Falls. And that point on the map is indicated there with the little red dot. One of the courses that I was teaching in the biology program was ecology. This is a 200 level course with a mix of majors and non-majors. My institution is a 2-year community college. It's a Hispanic serving institution. There are conventional students, unconventional students, so a good mixture of different people from all aspects of life coming into this class. The structure of my class included field work. I like to have my courses very field heavy. Also included case studies, and I'll talk more about what I mean by utilizing case studies, and a blending of just old school lecturing and textbook work. Between the years of when I'm teaching, so when I'm taking off in the summer, one thing that I like to do is make sure that I implement this idea that comes from evolutionary biology. And this is called the Red Queen hypothesis. This comes from a quote from the Alice in Wonderland novel sequel called Through the Looking Glass, where the Red Queen tells Alice, it takes all the running you can do to keep in the same place. From an evolutionary perspective, the Red Queen hypothesis means that species must continuously adapt to evolve just to maintain the same amount of competitiveness, because they are wrapped up in so much competition with other species that are also continuously evolving. But I take this out of context from ecology, evolutionary biology, and put it into pedagogy, meaning that every summer, if I have time, I like to take an element of my courses and work really hard to improve it in order to make sure that my classes don't go stale. And so, and for me as a teacher, make sure that I don't go stale. So during this time when I was finishing up my spring semester 2 years ago, I ran into this post from the Ecolog, and it mentioned the Faculty Mentoring Network, Ecology for All Undergraduate Audiences. After reading through the advertisement, it seemed like it was very likely that I would qualify. And I was considering at the time making another case study because I received lots of positive feedback from an initial case study that I built. This was a case study that implemented some of my work from my time as a PhD student at the University of Illinois at Chicago. Specifically, I studied frog calling behavior in northern Illinois, northern Indiana. I wanted to investigate the effects of anthropogenic noise on how frogs communicate to each other, and how that's linked to their mating behavior. So I created this case study based off of that work, and it was really fun, and it was probably my best product that I created for this ecology course. So I was considering doing it again. So after reading through this advertisement, it was pretty easy for me to decide to join the program. First of all, I get a stipend for doing something that I already should be doing. So obviously that's a bonus. In addition, I was kind of at the time really leaning into, and I still do, leaning into networking. So by that, I mean, I'm originally from the Midwest. I moved out west to Idaho, where we have sagebrush landscapes. I don't know anything about sagebrush habitat, but I want to have my ecology courses be really field-based. So the best thing I could do is just reach out to local land managers, people from Bureau of Land Management, U.S. Forestry, Idaho Fish and Game, to see if they would be willing to host our labs to learn more about these local habitats straight from the mouths of these experts. So I was doing a lot of networking, and I feel like I was benefiting a lot from that. And so I like the idea of continuing this theme of embracing networking and tying into the network of ecology teachers across the country. Finally, what I wanted to address with this program is a specific element of the 4DEE framework, which is this element of human environment interactions, because I figured that that was probably the weakest link out of these 4 elements that I had in my ecology class that I was kind of missing out on. So when deciding to choose this topic, it's important to put into context what I was going through at the time. In particularly, I was living in Idaho, but I was thinking about moving back to the Midwest. My wife and I just considered it would be best for our family to be closer to our extended family. And of course, that's not always a guarantee. So I needed to cover a species that live both out west and in the Midwest as well. And of course, beavers kind of check that criterion. The reason why I thought of beavers in the first place was because we were going out to these local natural sites, and we were running into areas where there was current beaver activity or remnant beaver activity, and the landscape looked just so different compared to the dry landscape surrounding it. In particular, if you were hiking through a landscape that had recently burned and you came across one of these waterways that had beaver activity, it would stand out greatly. Also, beavers are a historically intriguing species, especially from the perspective of Idaho, because in 1948, Idaho Fish and Game airdropped 76 beavers into the Idaho wilderness to reestablish them, to hopefully get them to kind of expand their range and claim back some of the habitat that they were extirpated from. They also have that cuteness factor working for them too. And in addition, they are part of this classic Yellowstone trophic cascade that we teach to our ecology students too, where we introduce wolves back to Yellowstone that changes the behavior of the elk herd. They feed less on riparian habitats. There's no more overbrowsing. There's a lot more habitat that's friendly to beavers. Beavers recolonize, change waterways. The fact that they're a key node to this story also just means that this is a great species to present to students, just so they're aware of all these cool stories that we can teach through this species. In most ecology textbooks, chapters 2, 3, or 4, they introduce this intriguing concept of the ecosystem engineer. This is a fundamental concept that describes a species that significantly creates or modifies habitat and affects the availability of resources for other species in that area. So if you can see in the middle of this diagram here, it kind of shows the long-term effects of beaver activity on a riparian habitat. You have more bioavailable hydrology because you're slowing down that water supply. You're increasing the flow further out side to side to that full bankful channel distance, creating a larger wetland habitat, and there's going to be a lot more infiltration of water into the immediate area. So I like to tell my students, beavers don't make it rain more, but they do slow down the average water molecule, how long it takes for that water molecule to go through a habitat, and in turn makes it more bioavailable for any species. And kind of stepping back and looking from a landscape level perspective, on the left-hand side here, this is just a basic net logo agent-based modeling program that we often use with ecology students. And it shows fire spreading across a landscape. And the idea about the benefits of beavers is if you don't have any beavers in a landscape and you just have all fuel, it's going to burn almost completely. But if you have beavers that have established themselves, raised the water table, increased infiltration of water into the surrounding, increasing the surface area of wetlands, well, perhaps instead of total annihilation of that forest, you'll have this patchy landscape. And over here on the right-hand side, you can see an area that was burned, and then beaver activity down the middle, showing that greenery, that place that didn't burn. And this adds to the idea of habitat resilience. In other words, the ability for this habitat to respond after a fire. Because if you think about these two options, the first option with total destruction of a habitat, in order for flora and fauna to reestablish, a lot of times they have to come from the perimeter. Whereas if you have a patchy landscape, yeah, you can reestablish yourself from the perimeter, but you can also reestablish yourself from this mosaic of refuges that the beavers have created. Continuing on with this intriguing concept of ecosystem engineering, I feel like sometimes textbooks fall short of one of the most interesting aspects of what it means to be an ecosystem engineer, because it's often viewed as a positive thing, but that's not necessarily the case. You're an ecosystem engineer, so you could change your habitat drastically, and that could be a good thing in a good context and a bad thing if you are in a new environment. So an ecosystem engineer is potentially an invasive species, and using the North American beaver as an example, it kind of provides this awesome global natural experiment, where in North America, we have their native home range. The species was overexploited. There used to be hundreds of millions of them. Now they're down to 10 to 15 million, but they're rebounding. In Europe, the North American beaver was introduced and is competing with the Eurasian beaver, or castor fiber. And in Patagonia, they're an alien invasive. They were brought down with the intention to farm their pelts. And you've heard the story before. Oops, they get out and they go wild, and they have no natural predators. The mechanism of changing the landscape is still exactly the same as what we want to see in North America. However, because they're out of that context of being in a community that co-evolved with beavers, well, now there is no wetland community that responds positively to these beavers clogging up these waterways. So instead of a force of adding to biodiversity, it's a force of destruction. So that's the nuance that I wanted to emphasize with this case study. So in order to build this case study, I did a few things. First of all, I write this out as ground truthing, but it sounds a little bit more sciencey and official than what it really was. I essentially just ran into sites when we were on our field trips that happened to have current beaver activity or remnant beaver activity. And I noticed that the environment looked different. Also, continuing on with this theme of leaning into networking, I had a job with the Forest Service in the summer, so I got to talk to a lot of local experts from the Forest Service. Also reached out to Idaho Fish and Game, the Feds, Fish and Wildlife Service, Bureau of Land Management, and other scientists from local colleges. From this networking, I interviewed a couple of natural resources managers because in particular, I'm not a beaver expert, and I wanted to make sure that I got this story right. And finally, during this whole time that we had the faculty mentoring network meetings that kept me motivated and kept me on track. So in the end, I ended up building this case study, which is a series of different activities with a similar theme that's supposed to emulate real science. It includes basic background natural history, a link to a video, a documentary about beaver activity, and basic terminology. But then as we start to ramp up the case study, it includes activities that you can do on field trips when you are looking at beaver habitat. In addition, different activities for actually restoring habitat by emulating beaver activity. So we'll get into that in a few slides. A couple questions that include persuasive writing. So thinking back on a couple slides ago when I mentioned that human environment interaction was something I wanted to focus on, a lot of farmers and ranchers see beavers as a pest, right? They can chop down some beautiful trees. They can change the direction of waterways that these farmers and ranchers want to control in order to flood a specific field at a specific time. And so this is really a big human obstacle too when we're talking about trying to reestablish the species across the country. Of course, it includes reading publications and interpreting data from primary sources, and a final set of synthesis questions. And so I posted this on the ESA website for different case studies, and What I tell people is just use it the way you want it. You're not supposed to use it from start to finish. Take what you can out of it. I'm happy to just provide anything that would be helpful for any ecology teacher. If you have a class full of non-majors, you might want to scale it down. Majors, you might want to use it all. If you don't have a lab component, you might want to skip those field components. But I intended this to be something that was just helpful for everybody. Right when I finished creating the final version of this case study, I accepted a job back in Iowa, back in the Midwest, which is closer to home. It's about 3.5 hour drive from Chicago. So I went from southern Idaho, which is a dry climate, to eastern Iowa, which is much wetter, mesic climate. And in addition, the story has to change too. Whereas the beavers were offering the dry western states this story of resilience after a wildfire. Well, wildfire is not that big of an issue in eastern Iowa and in mesic habitats. Instead, we face a different suite of obstacles. In particular, this huge corn, soybean, big ag. The entire state of Iowa is completely converted into corn and soybean, which means that we are suffering some of those negative externalities with big ag's priority of maximizing their yield. In other words, that we have high levels of nitrates and bacteria in our waterways. And in addition, this is not causation, but correlation. There have been studies that correlate high levels of nitrates with the higher levels of cancer across the state of Iowa. Last time I checked, which was yesterday to prepare for this talk, Iowa was ranked number 2 per capita for cancer rates. And across the Midwest, across the Corn Belt, this syndrome called blue baby syndrome is also an issue, which essentially is nitrate poisoning. So infants and pregnant expecting mothers should be really careful with their intake of water and make sure that their water is clean and filtered and have an acceptable low level of nitrates in the water. So reestablishing beavers in the context of Dubuque and the driftless region is a completely different story than out west, but the practices are still the same. So the idea in the Midwest would be if we can reestablish beaver activity, or if we can emulate beaver activity, well, those beaver ponds can raise the water table. We can reestablish riparian habitat. We can help filter nitrates out of the water supply, because if we set up buffers of wetland species and prairie species, native species between our farmland and our waterways, hopefully a lot of those pollutants get filtered out before water reaches the waterway. And in addition, beaver dams can help settle out some of those pollutants as well. So for those of you who are not familiar with Dubuque, Iowa, it is a beautiful city located right on the Mississippi River. It is easy to find on a map, even if you can't see Dubuque on the map, because it's located at the intersection of Wisconsin, Iowa, and Illinois. When I moved to Dubuque, I did the same thing that I did out in Idaho, which was I started networking, started talking to local experts, local land managers, local government agencies, in order to just help them teach my class, right? If we had different sites that these guys knew about, these gals knew about, taking our students out to the sites and hear about what they've been working on in terms of restoration and conservation, they would probably do a better job than me, who I'm trying to reestablish myself into a new area. And somehow it's one of those stories where I met a guy who knows a guy who knows a guy. I heard about this guy who was a forester who worked at New Melleray Abbey. So for those of you who don't know what an abbey is, because I didn't know until I moved here, this is a place where monks live. In particular, this set of monks, they live on the land and they're self-sustaining. So they have their own gardens, their own farmland, and they also tend to have their own specialty. So a lot of abbeys have a specialty of brewing their own beer. Now, this abbey doesn't have as fun as a specialty, but they do have their own specialty, which is to create caskets. And actually, this is really cool because in order to make sure that you have a sustainable business model creating caskets, you need to manage a forest. So they hired this man named John Schroeder, who is their forester. He is not a monk, but he does work on the Abbey every single day to manage their natural resources. So they have forested land. They also have some ag land that they rent out to conventional farmers. But this is a cool experimental site because they don't have the priority of maximizing corn yields like everybody else does. So actually, they give John a lot of creative license to do what he wants with his natural resources. And he's a very ambitious guy and has come up with a couple of big restoration projects. One of them being this idea of BDAs, also known as Beaver Dam analogues, or also known as just jump into a stream and act like a rodent. That's what we tell our students when we have our BDA days. So what these are an emulated, essentially you're just building a beaver dam out of local materials. It is very low tech. And now I have to warn you, I do have a silly little dad joke in here. It's also low stakes. I mean that literally, because the first thing that you do is pound stakes into the ground to set up your main structure for the beaver dam analog, but also you're just using mud, rocks, twigs, so you're not really risking too much. It doesn't cost a lot of money. It just requires a lot of human power. And that's exactly what I, as an ecology teacher, have for our field work. We just have a lot of students who have lots of energy, who are eager to get out into the field and to learn more about restoration techniques. So if you remember the diagram that I had a few slides ago about overall beaver activity and how they can change the landscape, it's a natural thing for beaver dams to break. So let's say we go out there and we do a bad job at creating BDA and that dam breaks. Well, it's not a big deal because that happens all the time anyways. So that's what I mean by low stakes. This is cheap. There's not a lot of power tools. It just requires just a lot of effort, and that's what we can provide, John. So over the past 2 years, we've been going out to the Abbey as at least one of our labs for our ecology class. And I've been receiving lots of positive reception. So I have a class that is a mixture of majors and non-majors. So for example, in this photo, we have an accounting major, flight operations, medical student who's pre-PA, and the rest of them are mostly environmental science students. But from the non-majors and the majors themselves, they seem to respond positively to this. So it's fun to go out into a stream, get muddy, get dirty, and do something that is really basic, like try to clog up the stream with any of the materials that you see around you. That, in a nutshell, is what building a BDA is. In addition, I'm going to use this word again, it kind of builds some personal resilience. So I want all my environmental science students to kind of get a dose of field work to make sure, okay, if you want this to be your career, are you comfortable being out in this cold water? These are very cold trout streams in the driftless region, just based off of our geology. A lot of our streams come from these really cold springs. So this is very cold water. There are leeches, there are mosquitoes, you fall over in the mud. And once again, this is polluted water too, with lots of bacteria and nitrates. So I think it's important to expose our environmental science students to some hard field work to make sure, okay, this is something that they want to do. But in addition, for our non-majors, perhaps some of them find this really fun and might want to reconsider. Perhaps I want to change my major and do some more environmental science because I like fieldwork so much. So it's good to have this test to physically test them to see if they like fieldwork and to just build up a little bit of physical resilience as well. And in addition, the reception from the internet, at least from when I checked yesterday, this case study was viewed 1,871 times and has 443 downloads. So as somebody who avoids all social media like the plague, this is as viral as I ever thought that I would ever get. In addition, this program allowed me to present at a conference and paid for my travels. And so last spring, I presented this case study and this program to the Mississippi River Research Consortium that was located in beautiful La Crosse, Wisconsin. You don't have to worry about anything that I have on this slide because this is essentially all the stuff that I've been talking about in this presentation. Back in the spring, I was impressed with these numbers, 234 views and 132 downloads. So clearly this is kind of catching on and a lot of people find this interesting. The one thing I do want to point out is my title, which a lot of people found funny, which is "Damn It." In this consortium, I ran into a lot of professors, graduate students, and undergrads, and it was helpful to get all their perspectives from 3 different levels to see if they responded positively to this type of case study. And indeed they did. So now I'm going to talk a little bit about what I am planning right now to do in the future. So this leads me to the research opportunity segment of this presentation. So going back to New Melleray Abbey, which is located just outside of Dubuque, about 25 minutes southwest. They own lots of land, some of it ag, some of it forest. They have, here's their Trappist caskets business. They have a landscape setup that also is a nice experimental design, natural experiment. So after 2 years of BDA building with my ecology class, John and I have worked together to establish this program that we're going to start up in the spring. So the natural experiment is as follows. We have a conventional stream that is located in an ag field. You've seen it before. It's just an ugly stream, corn on both sides. It cuts deep and sharp into the landscape, and it's full of just weedy species, low biodiversity. So that's kind of like our control site. Another very ambitious project that John has started that I haven't mentioned yet, that my class also has helped him out with, is this second stream here. He has planted a buffer around the stream. He planted it last year, so this is like ground zero for this restoration project as well. So we have the stream in the middle, which is blue. The light green is 100 meters of 100 meters of forest habitat, and then the dark green on the side is another 100 meters of prairie habitat. So the idea is hopefully from the ag fields that are surrounding this waterway, we'll be able to measure lower levels of nitrates that are infiltrating that water supply because of those prairie plants that are kind of able to filter out that water before any water molecule reaches that stream. So that's our second stream. And then our third experimental site would be this forested stream where we have been building BDAs. And I don't even know how many BDAs we have built, because my class is not the only one helping John out. And he has other BDA build days that I've joined him with over weekend days. And he's probably had other groups out as well. So we want to build a network of BDAs. And the idea is that we're going to emulate beaver activity, and potentially sometimes this actually attracts beavers. So the greatest thing that we could see is a beaver deciding, okay, you know what, you guys didn't do it too well. I'm going to take over this BDA and I'll show you how it's done. So then from there on out, it's just free restoration work that the beavers are offering us. So we're going to continue building these BDAs year after year with my ecology class, but also we're going to set up some longitudinal biodiversity and water quality tracking. So right now I'm talking with individual students, individual University of Dubuque students who might be interested in certain things. So for example, if we have a student who's interested in birds, we can do bird surveys. We can track amphibians, insects, mammals. I'm really open to anything because we're starting off at ground zero here for a longitudinal data set. So it could incorporate cameras, transect sampling for plants, pitfall traps, coverboard surveys, whatever we want to do. We're just going to have basically a biodiversity monitoring site, a couple of them on each stream, and then we will establish these survey techniques and continue them year after year to see what the effect is of these of this beaver activity and restoration techniques. In addition, because we have a lot of conventional ag land here that the Trappist monks rent out to conventional farmers, this could serve as a model of transitioning other ag land around the state into perhaps a native riparian communities, or reestablishing beaver activity, whether that's emulated or real, on their land as well. But there is a lot of pushback there. And I think it just boils down to the money. They want to make sure that they're compensated for the amount of land and the amount of yield that they lose by offering these riparian buffers across the landscape. But I really do think that if we can prove that this works, that it could change a lot of the state for the better, from a public health standpoint and from a biodiversity standpoint. So here's a look again, just from a satellite view of those 3 streams. Now I want to mention the overall impacts I've had with the 4D EE program. First of all, I think it's just a nice compass to use when you're revamping a lecture or an assignment. If you hit all of those 4 elements, then you're probably going to have a good product. And when you're looking through your past assignments and you notice that things just aren't clicking, perhaps it's because you are lacking in some of those elements. And that's what I noticed. It also helped me focus on making my assignments approachable for non-majors, because my class, both when I was teaching at the College of Southern Idaho and teaching at the University of Dubuque, has a significant proportion of non-majors too, and we don't want to leave them in the dust. In addition, from a networking standpoint, having those meetings with my colleagues from across the country, it was important for me to make sure that I just had my finger on the pulse to see, okay, are the challenges that I'm facing as a teacher similar to those across the country? And providing that back and forth feedback was a really helpful experience. And then after I moved to Dubuque, having this case study served as inspiration for further networking. And of course, like I just mentioned, these undergraduate research projects that we are starting up. Finally, I wanted to mention that this topic is trending. This is the National Geographic from a month or 2 ago, and they had a big article on beaver activity and also BDAs. And in addition, I want to call out this professor, Emily Fairfax. She is from the University of Minnesota, and she is one of the experts in BDAs and just restoration through beaver activity. Because once again, I want to stress, I studied frog calls as a PhD student. And I'm just now getting into this idea of using beavers to restore the habitat. So reading through some of her work has been important. And as well, John has invited Emily to help him out with designing the Beaver Dam analogues. And unfortunately, I had class that day when he had Emily out to New Melleray Abbey. So I was unable to make it. So I'd like to call her out, and I'd like to call out a few other people. In particular, the 4D EE crew, Justin, Erica, Teresa, and Joey. I would like to thank John, the forester, who's super ambitious and who is super open to having my students out on his site, helping him with his restoration projects, but also just collecting data. And also my interviewees from the U.S. Fish and Wildlife Service and Idaho Fish and Game, John White and Corey Mosby. Those are the BDA experts from the government's perspective that helped me make sure that I knew what I was talking about when I was building this case study. So that's all I have. I'm happy to answer any questions that you guys might have. Thank you for coming. So this is where the human environment interaction is such a intriguing and nuanced story where a lot of people have negative feelings about beavers, and it's for good reason. That their livelihood depends on managing their own land, and for generations and generations, we have just been focusing on yield and not necessarily on biodiversity plus yield. We don't really know how to balance that. And I feel like there's opportunity now because, to be frank, I mean, our yields are great and we create more corn than what we use. So when you're driving through Iowa, what you see is not food. What you see is ethanol. What you see is food for your food, which is corn that we feed to beef. or it's food for your food's food, which is legumes that help reestablish some nitrogen in the soil, so then you can plant corn in the future. So I think there's still potential there, at least from the ag perspective, to reestablish beavers. And I guess I would say there's just enough ag land to do that, where we don't really need to yet worry about residential areas. If there's a place where we could reestablish beavers and it's near a residential area, I think we could just prioritize somewhere else so we don't experience those negative effects of not knowing what the beavers are going to do, not knowing what the water will do next year. As humans, we like to know exactly where water goes all the time. And obviously that's not realistic, but I think there are bigger fish to fry than establishing beavers adjacent to residential areas, I guess, and like roadways as well and important infrastructure. There's plenty of other habitat that we can reestablish first.